Hello and welcome to my channel. Today we're going to talk about integration by parts. So firstly, we have to remember how to compute the differential of a product. And for that, we're going to do the product rule for differentials. So in this case, we get the first function times the differential of the second plus the second times the differential of the first. Now, if we're going to integrate this, put a parenthesis here. Let's rewrite it nicely. Gives us the integral of u dv, and by using the linearity of the integral, I can separate it as the integral of v du plus the integral of u dv. Now, the integral of a differential will be just the function uv in this case, and these two integrals, we'll just leave them indicated. So what we're going to do now is we're going to leave one of the integrals. Traditionally, we do this one. We'll leave this one on one side. We're going to subtract both sides, this one from both sides, from where we're going to obtain that the integral of u dv is going to be equal to u times v minus the integral of v du. And this is the formula that we will traditionally use for integration by parts. Now, what does that mean then? Let's say I have an integral of something of the form, let's start very simple, x e to the x. Now we observe this and we think, okay, so is there a way I could perhaps integrate this with just u substitution or some other method that we know from before, and we quickly conclude that we cannot do that. So what do? Well, we look at here, we have two different types of expressions. One will be u and one will be called dv. Now, traditionally, you're going to pick for u things that get lower in degree if they're polynomial when you take the derivative. So in this case, I'm going to pick u to be x. And du then will give me just dx by taking the derivative and multiplying times the differential. And then I get that dv will be just, I'm going to pick it to be e to the x dx. Now I can integrate both sides. So the integral of dv is going to give me a v. And then the integral of e to the x dx is going to give me e to the x back. So that's why I picked this as my first example, because it's easy. So let's move on to, I draw very straight lines, as you know. We're going to move on and try to put all this together. So let's take a look at what the formula says. I should have u dv equals uv minus the integral of v du. So now let's try to match what is what. So for example, here, x is going to be u. And so u will appear here one time, as it appears already in my integral here, and it's going to appear one time here. So when I plug that in, u is going to happen to be just x. Okay, so what is the other quantity we have? Well, we have v now that is going to appear in two locations. V, as we can see from here, is this quantity. Okay, so e to the x will appear where the red is showing up here. So that's going to be e to the x minus the integral of e to the x. And then I need to put in du. Let's do it with yellow. Du, I look at my table here, is going to be this one. And that right there is going to be just dx. So I get that that integral that I'm trying to compute is going to be x e to the x. And then minus the integral of e to the x is e to the x. And always remember to put your plus c. This one, then, just summarize it. The integral of x e to the x dx will now be factoring an e to the x out of this is going to be an x minus 1 e to the x plus e. So that's our first easy example. And so we'll continue with other examples here in a second. Okay, so let's go ahead and write another example. So this is another typical example. So something like x squared cosine of x dx. Okay, so this type of problems, soon enough, we're going to use a tabular method to solve them because it's a lot more straightforward. It's a lot faster. But using our formula, just straight up, we're going to pick u to be x squared. The reason for that is because when we take that derivative, we're going to be lowering the degree of that x squared into just 2x. So we kind of want to extinguish this term. So we're going to be picking that polynomial as u, so that we start dropping the degree until we are left with a constant, and then we can integrate. You'll see how it works here in a second. So now we pick dv to be our cosine, and we have to integrate. So integrating dv gives me v, integrating the cosine of x dx gives me sine of x. So plugging everything in place. So let's continue to this side. And I get u times v. So let's pick where u is. U is here. So I need an x squared that is going to be appearing here. Then I get a v that is going to be a sine x. And that's going to be appearing here. So my first term is going to be x squared sine x. So let's write that down. Minus the integral of now v, which I chose blue for, appears here again, which is going to be the sine x, but then du, which appears here, is going to be a 2x dx. So I need to put that in place. So what do we get in the end? I get a 2x. I'm going to have a dx, but I'm going to put it also the sine. Okay, so back to my colors. Red is right. No, red. Blue, as I said, is going to be the sine. And then, oops, and then yellow, which is the du, is going to be the 2x dx. So we have the blue and the yellow, they're there. So now we notice now that we have another integral to compute that's going to be typical for integration by parts, and I just noticed that I put this up here. Unfortunately, oh well, not gonna repeat everything for that, but let's take a look at what happens now. We still need to compute the integral of 2x sine x dx. So this is another candidate for integration by parts, because you think, okay, so how can I integrate this? There's two terms that are being multiplied. And again, integration by parts is a way to undo product rules. So whenever you have products of things, it's going to be often the case that you're going to need to do integration by parts. In particular, if you have a polynomial times a trigonometric function, that's almost likely going to be one of these cases. So let's take u as 2x. Now du happens to be 2 dx. dv will be the sine x dx. And then v, by integrating, get the integral of dv is v, and integral of sine of x is going to be negative cosine of x. And so we're going to plug it back in here. uv is going to be negative 2 x cosine x. I used, oh, I'm not going to put more colors because it get confusing with the ones above, but it's just doing uv. And I'm going to do minus v du. So then we minus the integral of v, which happens to be negative cosine, so this becomes plus cosine. And then the du, which is 2 dx. Let me put the 2 in front here and then the dx here. All right, and now I can integrate this where I get negative 2x cosine x. And now the integral of the cosine is the sine, so plus sine. And I'm going to now put or plug that in here. So let me color that one. I don't have a good color for it, do I? Well, let's do, no, highlighter is really terrible. Oh well, I'm just gonna mark it with green, even though that doesn't help much because everything else is green. So that integral, for that integral, I'm going to be plugging in this right here. So copy the x squared sine x, and then minus the integral of 2 x sine x is going to be negative 2x cosine x. One thing you got to be careful is that this negative right here, you're going to distribute to each term. So that first term is going to become positive 2x cosine x, and then minus, because this one was plus, but you had a minus in front. If you feel like you're going to make a mistake there, just plug it in with a parentheses and then deal with the signs afterwards. That's probably a much better way of doing it. But now I'm committed here, so just plus c. And that would be my answer right here. Of course, I can still factor a sine and a cosine and make it a little bit nicer, but that is, you can do it afterwards. So let's do it actually. Let's summarize it. So integral of x squared cosine x dx, summarizing everything, is going to be the sine x is going to multiply an x squared. Oh goodness, I just realized these two right here disappeared. I was hungry. Sorry about that. So minus 2. Thankfully, I went ahead and factored it because I noticed the mistake right there. And then plus 2x cosine x. And then plus c. Perfect. And that would be our answer.